Alright, this lesson is going to be on slope, and it is going to be linear equations or functions. So just like the last section, the equations have to be linear, meaning that they will make a straight line when they are graphed. So we are going to have to put them in slope-intercept form, and if they're not, then you need to solve it for that. So they need to be in the form of y equals mx plus b. Or if they're in function notation, it would be f of x equals mx plus b. M equals the slope, and erase that. B equals the y-intercept. So once again, if your equation is not in this form, meaning it's not solved for y, or it's not in this form, in the function notation form, you need to solve for y to put it in slope-intercept form to be able to graph it then. It makes it a little bit easier on that. So first of all, if we have an equation y equals 2/3 x plus 3, we know that the slope is 2/3, which means it's rise over run, if you remember back from algebra. And the y-intercept is 3. So that means that, since our y-intercept is 3, we make a point on 3. And our slope was 2/3 because it was y equals, we'll write it again here so you can see that. So I go up 2, 1, 2, over 3, 1, 2, 3, and put another point. Or I can also go down 2 over 3, and then I would connect those, and that would be my graph. It's a positive slope. It's rising to the right, as you can see, so it's going up to the right. And you know that because the slope is a positive 2/3, so that means it has to go up to the right there. Alright, let's just do another one with a negative slope. So let's say I've already solved for my equation. I put it in slope-intercept form. That means I've solved for y. So let's say I have a negative 1/2 x minus 1. So the y-intercept is negative 1. Right there, that's my y-intercept. And my slope is negative 1/2, so I go down 1 over 2, make a point. Or I can go up 1 to the left 2, make a point, and then once again I would connect those. So that's just showing that in slope-intercept form, those are our equations. So if they're not solved for y, you need to solve for y, then you'll know your y-intercept and you'll know your slope, and you can graph them from there. Alright, next let's say we just have 2 points. Let's say we have 1, 4 and 5, 2. So we don't have any any equation for this. They were just giving us 2 points on here, and they want us to find the slope. So since slope is rise over run, that means we subtract our y-coordinates over our x-coordinates. So I subtract my y's, that's my x, that's my y, that's my x, that's my y. So I subtract 4 minus 2 over, and you need to go back to the first one, because that's the one I started with. So I started with 4, and then I went to 2. So now I have to go back to 1 minus 5, so 1 minus 5. So I'd have 2 over negative 4, which would be negative 1/2. So that is my slope. So if I graph that, I'll just do a real rough sketch of that. So I graph my points, 1, 4. So that's 1, and that's about 4. So I put a point there. And I have 5. Let's say that's about 5 and 2. So those are my 2 points from the beginning. And graph those so you can see then that it's a negative slope. That's good because I found out that that's a negative slope. So I have a negative there. So it's going down to the right, and I can see that if I go down 2 over 4, or I can go up 2 over 4. So those are my slopes there on there. So anytime you're given 2 points, then you just subtract your y's, subtract your x's, just like you did, and that gives you your slope. And like I showed you, you can graph those by plotting the points and drawing a line. If I have a coordinate or 2 ordered pairs, 4, 3, let's make that -3, and 2, -3. So let's find the slope of this one. So I subtract my y's, which are -3, -3, and then subtract my x's, -4 minus 2. So I have -3 minus -3 is 0, and -4 minus 2 is -6. 0 divided by -6 is 0, so I have a 0 slope. If I would graph that, I'm just going to do a real rough graph here. So -4, -3 is about there, and 2, -3 is about there. That's -3, that's -4, that's 2. And you can see my line goes right through there, and it is a horizontal line. So if I have a 0 slope, line will be horizontal. So since it's horizontal, what do you notice about my 2 points up here? Well, if you look at that, my y coordinates are exactly the same. So if my y coordinates are the same, -3, -3, whatever they are, if they're exactly the same, then I will have a 0 slope. So anytime your y coordinates are exactly the same, you will have a 0 slope, meaning your line will be horizontal. If I have 5, 3, and 5, -4, then I go 3 minus -4 to find my slope, 5 minus 5, so I have 7 over 0. You can't divide by 0, so it's an undefined slope, or no slope. So it's undefined. So anytime your x's are the same, then you're going to have a vertical line. So if I would graph those, it would look like this. There's 5, and let's say that's about 3, so right there, and 5, and that's about -4. So there's my 2 points from the very beginning, right up there. It's a vertical line, not very straight there. Going through -5, so it's vertical line. So if you have a vertical line, it's going to be an undefined slope, meaning it's going to go right through the x-axis. And since it's going through the x-axis, my x-coordinates are exactly the same. So if my x-coordinates are the same, it'll be an undefined slope, and it's going to be a vertical line. All right, next we're going to look at parallel lines. So they once again have to be in the form y equals mx plus b, or function notation, meaning f of x. So if they're not solved in this form, you need to solve them and solve for y to get them in that form. So let's say I have y equals 3/4 x minus 1. So I'm going to graph that. My y-intercept is -1. So I go to -1. My slope is 3/4. So I go up 3, 1, 2, 3, to the right 4, 1, 2, 3, 4. And I would now connect those. Try the best I can. That's not too bad. So there's my line going straight through there. So now I have another equation that goes with it, and it is y, well, let's make it a different color. Let's make it red. Y equals 3/4 x plus 2. Now my slope then is 2, so I go up to 2. Or excuse me, my y-intercept is 2. And my slope is 3/4, so I go up 3. Make this red. 1, 2, 3 over 4. 1, 2, 3, 4. And go right through there the best I can. That's pretty good. So you notice I have 2 lines that are parallel. And if I look at my 2 equations, what do you notice about my slopes? If you look at my slopes, the slopes are exactly alike. the y-intercepts, negative 1 and 2, that doesn't matter. We don't care what the y-intercepts are. All we care about is that the slopes are exactly alike. If they're exactly alike, then they are going to be two parallel lines. They can go, these are positive. They could also go down to the right like this if we wanted to. It's just be negative slopes. But the slopes have to be exactly alike, like they are here, in order for them to be parallel lines. Alright, and the last ones here are perpendicular lines. Perpendicular lines, if you remember back from geometry, two lines that are perpendicular means that they form a right angle. So we're looking for two lines that intersect and form a right angle. So if I graph this first one, the y-intercept is negative 1, so I go down to negative 1. Slope is 3/4, go up 3, 1, 2, 3, over 4, 1, 2, 3, 4. And that's pretty good. Now I'm going to graph the other one. I'll do that in green since it's already in green. Y-intercept is 2, so we'll put a point there. And the slope is negative 4/3, so I go down 4, 1, 2, 3, 4, over 2, or 3. And let's see if I can make this one very straight. Not too bad. So, since these are perpendicular, because I told you that they are, then these areas here are all 90 degrees. So if you look at a perpendicular lines, what do you notice? Well, I notice that the slopes are opposites, meaning one's positive, one's negative, and they're also reciprocals. So one has a positive 3/4, the other one's a negative, and they're also the reciprocals 4/3. So if you have two lines or two equations, and you look at them and their slopes are opposites, one's positive, one's negative, reciprocals, meaning you just flip the other one upside down, then the lines will be perpendicular. You don't care at all where they cross the y-intercept, so you don't care at all about that point. All you care about is the slopes. If the slopes are opposite reciprocals, then it's going to be perpendicular. Another example, let's say I have a slope of 2. What's the opposite reciprocal of negative 2? The opposite would be positive. The reciprocal of 2 is 1/2. So there's the opposite reciprocals. So if I would graph that, can't graph that because I don't have any points. Those are just the slopes. Those are opposite reciprocals. That would make a perpendicular line. And the last part, if it's neither parallel or perpendicular, that means that the slopes are not the same and are not opposite reciprocals. And I think that should do it for slopes and parallel and perpendicular lines. So, hope this helps you. See ya. Bam!